2022, we detected high-risk Chinese surveillance cameras, just like these on the table in front of me, that were stealthily built into U.S. infrastructure systems. We leveraged our Skyfall laboratory to develop an advanced beacon detection analytic that increased sensitivity to detect these threats while improving selectivity to dramatically reduce false positives. When we deployed the analytic to CyberSentry partners, almost immediately our analysts detected anomalous beacons on the OT network of a participating company. Our team identified the beaconing device as a camera manufactured by the Chinese company Dahua. Livermore developed a machine learning model to detect these devices at scale and deployed it. We found cameras on most of the participating CyberSentry entities, in some cases hundreds of them. Network traffic showed that these devices were beaconing to suspected hostile overseas servers. Some appeared to be transmitting encrypted video. Reverse engineering of the devices revealed they were also capable of providing a backdoor to any connected network. Notably, these devices were mostly sitting on OT networks, providing direct access to the physical processes. We worked with CISA to create and publish a set of playbooks that went out broadly to help asset owners who are not part of CyberSentry detect these devices on their own systems. This illustrates how the CyberSentry partnership between just a few dozen critical infrastructure asset owners, national labs, and CISA enhances cybersecurity across U.S. critical infrastructure. It's important to recognize detection represents just one aspect of defense against cyber threats to our infrastructure. The current threat picture demands a multi-layer approach. At Livermore, we use what we call the Immune Infrastructure Framework. This four-layer approach recognizes that we can't stop all attacks and instead seeks to make it as difficult as possible for adversaries to achieve their goals. Layer 1 focuses on understanding critical infrastructure systems through modeling, simulation, and analysis. This essentially allows us to look at U.S. infrastructure through the eyes of our adversaries. Layer 2 attempts to keep the adversary out of our systems through supply chain assurance. Layer 3 focuses on detecting and responding to intrusions. We put significant focus on addressing the previously unseen over-the-horizon threats that China, Russia, and Iran are developing that could hold our systems at risk. In Layer 4, we engineer our systems to operate through compromise by using techniques like collaborative autonomy, which are designed to provide redundant, decentralized control of systems. While all 16 critical infrastructure sectors are important, we pay particular attention to energy, water, transportation, and communication because of their close connection to national security.